In this example, we're told that there is some length of railroad that is 5 kilometers long, but it expands on a hot day by 15 centimeters. Now, right off the bat, I see two different units, and so I know that I'm going to need to make some type of conversion. So let's convert this kilometers into centimeters by multiplying by 100,000. That's a conversion factor. So that gives us 5 kilometers is the same as 500,000 centimeters. But on a hot day, this railroad expands. So we can say it kind of bows up like this, for instance. Now, it's not going to be perfect, but it is a good enough approximation to find this height. That's what we're looking for, is how far will the center rise above the ground. It would be acceptable here to approximate this by drawing in two right triangles, like so. These are right triangles. So I'm going to say then that those two black segments, these two hypotenuses together, would be 500,015 centimeters together, because that's approximating the expansion in centimeters. So next, what we need to do is get some measures on the actual triangles themselves. So we've got lengths of two hypotenuses, and if we want just one, let's divide that by 2. So 500,015 divided by 2 would give us that just one of these lengths, say for instance this one here, would be 250,000 7.5, I think I missed a 0, sorry, 7.5 centimeters. And then next, we want to do the same type of thing with one of the legs here. So all the way across in blue, what was originally in blue was 500,000, so this one leg would be 250,000 centimeters. Okay, so after that, now I can use Pythagorean Theorem to help me estimate this height. And I'm just going to call that height, let's call that h. Okay, so Pythagorean Theorem says that a leg squared, so in other words, 250,000 squared, plus the other leg squared, which is h squared, equals the hypotenuse squared, which in this case is 250,000 7.5 squared. So what we want to do from here is solve this. I could square each piece, and those numbers are very large. I think I wrote them down here earlier. Yes, I had, this one was the following. And the other value would be 2, a whole bunch of zeros. I believe I want to say 8. All right, so to solve that, I would need to subtract this value on both sides. All right, and I definitely would use a calculator here. It's just that I have already typed these values in to speed up the video process. So I get the following when I subtract. And then the last step would be to take the square root of both sides to undo the squaring. And I get, when I round that to the nearest hundredth, I get 1,936.51 centimeters. Now, I need to be very careful because the question asks approximately how many meters above the ground, not how many centimeters. So this is the height. This is how far it has expanded above ground. But to change that into meters, I would want to multiply by the conversion fact that 1 meter is the same as 100 centimeters, or some people say, well, that's the same as dividing by 100, and that converts my units into meters, and that would be 19.4 whenever I round to the nearest tenth, as was asked in that